class 5. Welcome back after the vacations. I hope you all are safe and you had a good vacation at home. Today we'll be doing chapter number 3. We have done chapter number 1, 2 and 4 before the vacations. So chapter number 3, I'll be taking you through the content and I'll be explaining to you. So once this video is over WhatsApp, you can ask me your doubts. Okay? So today's chapter is chapter number 3. Flow charts and algorithms. Okay? So just you go through the content and over WhatsApp you will ask me your doubts. We'll be finishing a part of the chapter today and a part I'll be taking in the next class. Whatever is not clear, we'll discuss. Good morning, class 5. So this is the continuation of chapter number 3, where we'll be speaking about what are the rules for making a flowchart. So there are some rules which should be followed while making a flowchart. While drawing a proper flowchart, all necessary requirements should be listed out in a logical order. So if you have not listed out the requirements already, what will happen? You will keep erasing and redrawing things. So first you should all have a algorithm in place. A flowchart should be clear, neat and easy to follow. So this is a rule that you will not draw freehand. Okay, you will use scale and pencil. I repeat again, we will be using a pencil so that we are able to do some types of corrections if needed. We will not draw the flowcharts with pen. Second thing is, we will not draw flowcharts with freehand. We will have to use scale and pencil. Only one flow line should be used in conjunction with the terminal symbol. So there should be only one flow line which should go to the stop statement, okay, the stop symbol. The direction of flow should be from top to bottom or from left to right. So we should not be making our flow go from bottom to top. One thing is, the flow will always be from top to bottom and from left to right. The lines should not cut each other. So avoid the intersection of flow lines if you want to make it more effective and better. Because if the lines intersect, then we don't know which flow we are following. Are we supposed to go down, or are we supposed to take right, or are we supposed to take left? So the flow lines should not intersect. If the flowchart becomes complex, it is better to use connector symbols to reduce the number of flow lines. So if the flowchart is very big, then we should use connectors and break it into smaller parts. Now converting an algorithm into a flowchart. The example here is go to the school. Okay, the objective is going to the school. So we'll have to look at the algorithm and the flowchart simultaneously. What we understand here is step 1 is start. In the flowchart we have the oval symbol which says start. Wake up in the morning, small simple sentence is in a rectangular box. Wake up in the morning. Then go to the washroom, simple sentence is again in a rectangle. Brush your teeth, take a bath, wear your school uniform, have your breakfast, take your tiffin, go to your school, and that is the objective. Now we stop. Now over here in the flowchart, if you see, the flow lines are just touching the boxes. Okay, they are not entering into the box, neither at the top nor at the bottom. Second thing is the start and the stop box, which are oval boxes where start and stop is written in the box. Next, in this example, we only have processing box, that is a rectangle, and these are the simple sentences. Okay. So this is how we convert an algorithm into a flow chart. Now we go to the next example, adding two numbers. Over here we have something called input and we have something called output. So the example is start. Take two numbers gets converted to input n1 and n2. Okay, we are asking the user to give me two values n1 and n2. Next is a simple calculation, that will be a processing box. Sum is equal to n1 plus n2. Okay, so sum is equal to n1 plus n2 is a simple statement, that is processing box. And input is in a parallelogram. Then print is output. Okay, the print the result, print sum. So if you see, sum is equal to n1 plus n2, so we get the result in sum, and then we say print sum. So our objective is met, we got the result by adding two numbers, and then we stop. Now to find the area of a rectangle, area of the rectangle is length into breadth. So let's say A and B. So what we are doing here is start, get the values from the user. What is the length of the rectangle? What is the breadth of the rectangle? Okay. Input A and B, area is equal to A multiplied by B. Then output, print area. So I hope it is making it clear that we are using parallelograms for input and output and simple rectangle box for simple statements and simple calculations. Okay. The last step in solving a problem is to convert the flowchart into a program. This can be written in the computer language to get the desired result. Now the way we have done algorithm changed to a flowchart, the same way we convert a flowchart into a program. Okay. There are many computer languages. You have learnt about some language in the previous chapter of this book, have we? We have learned about high level languages, machine languages, right, in the previous chapter. So this finishes our chapter. What we have learned in this is that the computer understands instructions in its own language, that is the machine language. Step-by-step instructions given to the computer is called a program. Algorithm is a step-by-step procedure to solve any particular task, and algorithm is very close to English language. Flowchart is a diagrammatical representation of a problem solving process, and each operation in a flowchart is represented using specific geometrical symbols. So this finishes our chapter here. Please come up with your doubts, whatever questions you have. Thank you so much.